One of the most important skills that we'll learn in this course is how to identify and describe relationships that appear in data. So let's take a look at our very first example of this. This data shows the cost for producing tables. The data says that if we don't produce any tables at all, we still spend $80. These are fixed costs having to do with maybe purchasing the tools or purchasing other kinds of supplies. Even if we don't make any tables at all, we still have to spend this money. To produce one table is $92, to produce two tables is $104, and so on. And we'd like to look at these costs and try to identify some kind of pattern and describe that pattern. The first pattern you might notice is that to step forward one table, we increase the cost by $12 each time. We have to pay $80 no matter what, and then to make one table is plus $12, and to make two tables is another plus $12, and to make the third table is another plus $12, and so on. This plus $12 is sometimes called the first difference, and it just means that we identify how much do we need to add to get from one entry in the table to the next. So we have to add $12 to 80 in order to reach $92. Once we notice this constant increase of plus 12, we could write the costs in a slightly strange way. We could say that to make 0 tables costs $80 and we add 12 no times. And to make one table is the $80 we have to pay plus $12 one time because we're making one table. To make two tables would be the $80 we must pay, those fixed costs, plus $12 two times to make the two tables. The reason we might write it in this way is that it suggests a pattern that we can capture in an equation. The cost in producing the tables is equal to the $80 in fixed costs that we must pay no matter what, plus $12 for each table that we produce. Another way we might visualize this data instead of presenting it numerically is to present it as a graph. Each of the blue dots in this graph represents one piece of information from the numerical data. So for example, the blue dot on the far left is at coordinates 0 and 80. That means that to make 0 tables still costs us $80. The next dot is at coordinates 1 and 92. We can't exactly see that accurately in this picture, but we remember from the table that to produce one table costs $92. When we graph all this data, we see that it perfectly fits a straight line. The reason for that is that each time we add another table, we add a constant $12 to our cost. In the graph, this means that every time we move to the right by 1, we move up by 12. And this produces a nice constant increase in the graph. The advantage of writing down the equation algebraically is that now we can get information that we didn't originally have. So what is the cost to produce 10 tables? If we look at our equation, we see that it has two variables right now. One of them is cost and one of them is tables. The information that we're given for this question is the number of tables. And the information we want to know about this question is the cost. So that means I should substitute 10 for the value of t and try to compute the value of c. If I do all the arithmetic, I see that this works out to a total cost of $200. Another type of question we could ask is, if we know we're willing to spend $260, how many tables can we produce on that budget? This time what we know is that the value of c should be the $260, and it's the number of tables that we're trying to determine. So if I substitute 260 for c, and then I should try and solve this for t. So I subtract 80 from both sides, and then divide both sides by 12, and now I've isolated t, and I see that I can produce 15 tables on a budget of $260. This particular example exhibited a linear relationship between the number of tables we can produce and the cost of producing those tables. We'll talk more about these kinds of equations later in the course, but for now we can just say that a linear equation models repeated addition of a constant value. That is, just like we noticed in this example, we added 12 every time we created another chair. That's the repeated addition that we're trying to model. The equation that you get from such a situation is always of the form y equals a plus bx. A is the starting value, just like the fixed cost of $80 from this example. And b is that fixed amount that you add every time you increase the value of x. So for our example, b was 12 because we add $12 every time we produce a new table.